Hello everyone, in this video I'll discuss about relative velocity. Let's understand the stationary and moving frame of reference. In this figure, the frame S is a stationary frame of reference and it has velocity 0. The frame S prime is a moving frame of reference moving with velocity vector v s prime s. A particle P has velocity vector vps in the stationary frame of reference and vector vps prime with respect to the moving frame of reference. We are interested in obtaining a relation between these three velocities. The position vector of the particle with respect to stationary frame of reference is vector r0 and with respect to moving frame of reference is vector r. The position of origin of moving frame of reference is vector rf. So using triangle of vector addition, we can write vector r0 equals vector rf plus vector r. If we differentiate both the sides with respect to time, we will get vector vps equals vector vs prime s plus vector vps prime. If we take the relative velocity term vector vps prime on left hand side, we will get vector vps prime equals vector vps minus vector vs prime s. So this formula can be used to obtain the relative velocity of particle with respect to a moving frame or a moving body when the velocity of the particle with respect to a stationary frame and velocity of moving frame with respect to a stationary frame is given. Let's consider two bodies and the moving frame is attached with the body B which has velocity vector Vb. The absolute velocity of body A is vector Va. So in this case we can obtain vector Vab as vector Va minus vector Vb, and we can obtain vector Vba as vector Vb minus vector Va. So these two relationships establish a third relation as vector Va equals minus vector Vba. So when two bodies are moving in same direction, let's assume that the direction is positive direction of x-axis, we can write the relative velocity of body A with respect to body B as vector Vab equals Va I cap minus Vb I cap, and the modulus of this relative velocity will be Vab equals the modulus of velocity of body A minus modulus of velocity of body B. In the second case, when the two bodies are moving in opposite direction with the velocity vectors Va and vector Vb, the relative velocity vector Vab will be vector Va I cap minus of minus Vb I cap. So we will get the modulus of the relative velocity Vab equals Va plus Vb. Let's solve a question based on relative velocity. Rain is falling vertically with velocity vector v. Find the direction in which a person moving horizontally with velocity vector u should put umbrella to avoid getting wet. So this problem can be shown with the diagram here. The man is moving with velocity vector u and rain is falling with vector v velocity. So the direction of umbrella should be opposite to relative velocity of rain with respect to the man. So we can write the direction of umbrella to be minus of vector vrm, which will be equal to vector vmr. And according to the definition of relative velocity, we can write vector vmr equals vector velocity of man vector u minus velocity of rain vector b. So these two vectors difference can be shown in the graphical manner as vector u and second vector minus vector v. So if we find the resultant of these two vectors, we will obtain the direction of umbrella, which is vector vmr, and this is shown in arrow here. So this vector will be the direction of the vector in which the umbrella can be put.